Okay, so this is a follow-on to the previous quick discussion about molarity. And I pose a problem. The problem goes like this. How much carbon dioxide vapor and water vapor how much is produced when a half a liter of strong vodka, 160 proof, is burned? Okay. Now again, we've talked about this reaction before, and so I'm going to gloss over the reaction, although I'm going to draw it in a second again, just as we do our calculations. But I'm going to focus now on the concentration aspects here. Again, this is typically the kind of problem that you'll see in chemistry, because the amount of, especially with liquid reactants, you're always kind of given how much of a reactant are you using. In this case, how much of this really strong vodka. We're going to imagine that it's 80% and not 40%. How much of the strong vodka are we going to use in our experiment? In this case, the answer is a half a liter. Okay. So I want to take you kind of through this problem, and we'll see what's involved. Okay. So first things first is we have a half a liter of something, and we want to know how much ethanol is in that. And also kind of conversely, how much water is in that as well. Now, I'm going to assume that the strong vodka is made up of really nothing significant beyond ethanol and water. Of course, vodka has some trace things that give it flavor or whatever, but we're going to kind of ignore them at the moment. Okay. So first off, let's talk about the concentration here that they're giving. The units that they're giving us is in proof. Now, this is not a scientific term at all. This is more like an everyday term. But proof is really just an indication of the alcohol percent by volume, and the number is actually kind of twice the percentage. So 160 proof is really the same as 80% alcohol by volume. Basically, it's a volume percentage of alcohol. Okay. So first thing I want to do is on this one is let's figure out how much ethanol are we talking about. Because if we know how much ethanol it is, then if you remember what we did before, we can easily use the stoichiometric chemical equation for burning ethanol, and we can find out how much carbon dioxide is produced for every gram of ethanol. We can figure out how many grams of carbon dioxide, and we've done that calculation before. But we're not being told the amount of ethanol, or not how many grams anyway. We're given a volume of liquid, of solution, and a concentration of alcohol. Okay, so 80% alcohol by volume, essentially all that means is that we have 80 liters of alcohol for every 100 liters of solution, of vodka in this case. Okay, and what we actually have is a half a liter of solution. If we multiply that out, we'll find that we have 0.4 liters of alcohol, of pure ethanol, in the half a liter. In the 0.5 liters of vodka, we have 0.4 liters of alcohol, and then just by arithmetic, we know we have 0.1 liters of water. Okay. All right. So we'll take that and we'll set that aside. But 0.4 liters of alcohol. Remember, we want to get to grams or moles or something so we can use our chemical equation. But how do we get from liters to grams? Well, that's something that's a very common chemical term. It's called density. Density is a chemical characteristic of all substances, but it allows you to basically say for any volume of substance, what is its weight? And we're familiar with some substances that have a really high density, like lead. Lead is really heavy. For a little piece of lead, it's really, really heavy. But something that's light might be, I don't know, feathers or something that even if you have a big pile of feathers, it doesn't weigh very much. So that would be something of low density. So density of alcohol, you can look all these things up in a book, and I looked up the density of alcohol, and it is 0.7, I'm sorry, let me draw it different. It is 789 grams per liter of alcohol. Okay? So if we know we have 0.4 liters of alcohol, we can just multiply by its, put the units there, 0.4 liters of alcohol. We can multiply by 780 grams per liter, and the liters cancel out, and we'll be left with grams. We'll multiply that out. We end up with 316 grams of alcohol. Okay? Which we remember before, we can convert that to moles easily enough. 316 grams divided by 46 grams per mole. Remember, 46 was the molar mass of ethanol, which, just to recap, I showed that calculation here. The molar mass of this compound, of ethanol, is 2 times the molar mass of carbon, which is 12, 6 times the molar mass of hydrogen, which is 1, and 1 times the molar mass of oxygen, which is 16. Add it all up and you get 46. So if we take this and we divide it out, we end up with 6.9, I'm going to call it 7 moles. All right? Yeah. 7 moles of alcohol. So in our half a liter of strong vodka, strong meaning 160 proof vodka, there is 7 moles of alcohol in that solution. Okay. So then back from our earlier conversation, from our earlier reaction that we drew. If you remember, I'm going to draw it here real quick. That the ethanol burning reaction is C2H6O plus 3 oxygens yields 2 carbon dioxides and 3 waters. Okay? And if you remember, you can always multiply this equation any way you want. I'm going to actually, just for grins, I'm going to multiply by 7, because that's the problem that we're given, is we have 7 moles of ethanol. So if you multiply this by 7, you end up with 7 ethanols and 21 oxygens, yields 14 CO2s and 21 waters. Okay? And the reason I use 7 there is that that's the problem that was posed to us, is when you burn a half a liter, blah, 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 what happens? Well, we did our calculation using the concentration information they gave us and the density of ethanol, and we figured out that the problem started with 7 moles of ethanol. So now that we have this nice little stoichiometry equation with 7, it's easy to answer the question of how much CO2. When you burn 7 moles of ethanol, you end up with 14 moles of CO2. Again, we already know the molar mass of CO2 is 12 plus 2 times 16 is 44. That's the molar mass of CO2. So 14 moles of CO2 times 44 grams per mole is going to give this much CO2. $616. So one of the answers to the question is how much CO2 is produced. That's how much. 616 grams of carbon dioxide will be produced when you burn a half a liter of strong vodka. How much water is produced? Well, first of all, that's a trickier one, because we can calculate how much water is produced by the chemical reaction. It's 21 moles of water times the molar mass of water, which is 18. If you multiply this out, you get 378 grams of water that's produced by the chemical reaction. But if you remember, we actually had more water. We had some additional water in the vodka, right? The vodka had both ethanol and water. So now, this amount is not sufficient. This is all the water that we produce by burning ethanol. but we actually boiled some water as we were burning off the vodka. The water that was in there with the vodka is also being vaporized during the burning process. So we have to account for that water as well. How much water is that? Well, let's go back. Let's save this. Let's erase our math. Okay. And we're kind of done with our reaction now because we have the value from the reaction right here in the boxes. But I'm going to go back to our original problem, which is 0.5 liters of 80% vodka was basically 0.4 liters of ethanol and 0.1 liter of water. So it's this 0.1 liter here that we need to account for in terms of the extra water produced by burning this much vodka. All right, how many grams is that? Well, we're going to use the exact same thing. What we have is 0.1 liters of water, and we need the density of water. Well, the density of water, thankfully, is right around 1. In fact, that's not even a coincidence, but we'll get into that in a second. The density of water is 1, roughly, grams per liter roughly at room temperature. And so when you multiply this out, 0.1 liter times 1 gram per liter ends up with it's 1 gram per milliliter. I'm wrong about that. 1,000 grams is what I should have said. Liter. It's 1 gram per milliliter. 1,000 grams per liter. Multiply this out, you end up with 100 grams of water that was essentially contained in the original amount of vodka that we started to burn. So the answer to the question is how much water vapor is produced. It's 378 from the reaction. It's the 100 that we boiled off as we were burning the vodka. So it's 378 plus 100, or 478 grams of water total. Okay. So that's it. That's the problem. And again, water chemistry is very important. We're going to spend a lot of time talking about that. We'll spend some more time talking about this in chapter 4 as well. And then, of course, once we get to biological chemistry, it's all over the place. Okay, that's all for this one.